So welcome guys, welcome back, and let's solve this confidence interval problem. Actually, I received a lot of doubts about confidence interval from the students. So this is our step to help the students solve some problems and get some ideas about it. So confidence interval of a parameter is nothing but a comma b, where a and b are functions of the data. So this gives like the probability of the parameter not lying in this region is not that. The probability of the parameter is not a random variable here. So it's a fixed number like which we need to know. I mean to find out from the data. So actually we'll see. Let's take this example and we will find that out. So let's observe that. What does it really mean? So let's solve this problem first. So the idea that this so let's understand this problem. So this is x1 x2 x10 is a random sample from um, shifted exponential. The shift parameter, the location parameter is mu over here, and the idea is that you have to find the confidence interval for this location parameter mu. So this is a confidence interval. What does it mean by a confidence interval? It means that mu is like by this interval. It means that this one is the x1 is the minimum order statistic over here. So it means over here this x1 minus certain constant c is less than x1 and x1. Mu is less than this. The probability of this happening is 90%. Okay, 0.9. This is the problem. But you understand, mu is not a random variable, it's a constant. So actually the problem is telling you is that this is equivalent to saying that probability x1, if you observe it very carefully, x1 is greater than mu and less than mu plus c. Iska probability is 90%. This is equivalent, right? So it's asking that the probability of this minimum order statistic greater than mu and less than mu plus c is 90%. This doesn't make any sense in terms of mu, because mu is just a constant. But it makes a lot of sense in terms of this x1. So it's equivalent to this. Like this is equivalent to this, and therefore we need to find the probability of this one. So it's asking that x1 minus mu. So if you observe it very carefully, we need to find out probability x1 less than mu plus a constant and less than mu, okay, greater than mu. Iska is 90%, okay, and observe that probability x1 we will shift it, and I will tell the reason why. This is equal to 0.9. So it's telling that x1 x2 xn follows shifted exponential the location parameter mu, and 1. Okay, 1 is the red parameter. So observe that x1 minus mu, if you observe it very carefully, since the location parameter is mu, it shifted towards like after mu x greater than mu. So if you just replace, if you just transform all the random variables to this, can you just tell me what this is? This is nothing but exponential normal, like let parameter 1. So the location parameter is 0, which is essentially equivalent to x, like the normal exponential that we know. And if this happens this way, let's call this y1, y2, yn. So here, what is x1 minus mu? X1 minus mu is a minimum order statistic, right? Of xi's minus mu, which is equivalent to y minimum order statistic of the y1s, because it's a linear transformation. Okay, it's just like a linear transformation. By linear transformation, I mean that here it's just some constant is subtracted. So the minimum of all set of numbers is same as like the transform one minus mu, right? That's exactly the thing, that because it's the nature of the transformation that we are looking over here, right? And we have got this x1 minus mu is equal to y1. Now yi's are all exponential one, and you know this interesting result that if a y1, y dot yn follows exponential 1, then the minimum order statistics y1 follows exponential sum of all the parameters if they're independent. That's 1 plus 1 10 n times, so exponential n. And therefore here the n is equal to 10. So here y1 follows exponential 10. Here the n sample size is n, right? Very good. So therefore x1 minus mu, the x minimum or minus mu follows exponential 10. Follow exponential 10, right? And thank you. Yeah. So it follows exponential 10. And what we got over here is that we need to find out the probability what? We need to find out the probability that x1 minus mu is less than c and greater than 0. So therefore, we need to find out the probability that exponential 10 ka, so this is nothing but integration, since this is exponential 10, it's nothing but integration. What? If you observe it very carefully, it's nothing but 0 to c 10 times e to the power minus 10x dx. And your homework is to find out the solution of this and show that I think I have not done any mistake, but as far as I remember, it's equal to 1 minus e to the power minus 10c. This is what I remember. And yes, this is e to the power minus 10c. Now, if you observe, this needs to be 0.9. So we get that e to the power minus 10c is equal to 0.1. And we get that minus 10c is equal to, it's 1 by 10, it's minus log 10. It should be minus log ln 10. Ln is its base e, it's 1 by 10, so it's ln 10, right? So here it will be, c must be turning out to be 10 to the power 10. Oh no, sorry. C is turning out to be 1 by 10 of ln 10. C is turning out to be 1 by 10 of ln 10. Is it given over here? So no, it's given something else. So this is not a 90% confidence interval, because for it to happen 90% confidence interval for this, with this C varying, we will be needing C is equal to 1 by 10 of ln 10. But here we have something else. So it's not a 90% confidence interval and it's a false. So this is what is an idea. This is an idea of confidence interval, how you calculate it. It's just based on basic probability, guys, okay? And you see you introduce two important results. One is minimum of all the exponential sum is some independent exponential sum is some of the red parameters, and that add it up. That's one important result. And confidence interval I have already told you in the beginning. So I hope you enjoyed this, and I hope you learned a bit about confidence interval from this, and how you hope you you're in a clarity of confidence interval has been a bit more better. Thank you guys for being here. If you enjoyed it, please do like, share, and subscribe to our channel, and do share among your friends, guys, who really need this help at this moment of time. And all the best. And yep, all the best for ID Jam that are coming soon. And see you in the next video. Stay tuned and stay blessed. Bye bye.